Hello and welcome to physics. You are going to be going through a graphing example, and you have the paper with you and hopefully a ruler, and I will be going through it on the screen like so, and it should make sense. So here is our example. Look at all that data. We got time, velocity. It says a car is driving down a road and begins to accelerate. Its velocity is recorded over time and is listed in the chart. Create a graph of the data. We can do that. So here is our grid, and we make good graphs. So it's going to have a title. It's going to have axes that are labeled. So we've got time and velocity. Time is independent, velocity is dependent. So velocity depends on how much time has occurred. So velocity is going to go on our x, on our y. Time will go on our x. And we've got units, meters per second and seconds. Okay, and then as far as a title for the graph goes, we always do y versus x. So look at that. Velocity of a car versus time. Okay. So now what we want to do is we want to figure out what numbers to put along our axes, because we don't want to be squishers. We don't want to squish our data down into one corner. We want to spread it out so we can see it. And look at that. Whoever made this question gave us 10 seconds and 10 along here. What a day. Velocity, our lowest velocity is 4. Our highest is 35. So how about that? 0 to 10 along the x, 0 to 40 on the y. So you can pause the video if you want and get all of that in, including the data points. So don't make your line yet. Don't connect dots. Just put the points in. Go ahead. Okay, so here are the data points. They go from here all the way up to there. And we have to think about what kind of relationship that is. It doesn't look quadratic. It certainly doesn't look inverse. What do you know? This kind of looks like it's linear. Okay, so now what we do is we make a line of best fit. A line of best fit is not connecting dots. It is finding the trend in the data, and boom, there's my line of best fit. And it might not even go through any of the data points, but this certainly shows the trend of the data. And once I've got that, I don't even care about these data points. What's important is the line. Okay, your line, your special little line. That's what's important. Okay, this is linear, and so that follows the formula y, velocity, is equal to m, which is the slope, times x plus b. X is time, b is our y-intercept, where it crosses the y-axis. So we'll first think about slope. So slope is equal to y2 minus y1, right, the rise, over x2 minus x1, the run. Okay, so rise over run. So I want to pick 2 points. And again, I'm not looking for data points. I'm looking at my line, and preferably parts of the line that go through the grid. So this point up here, that's a fabulous point. Look, it goes right through 8, 28. Same with this point here. The line goes through 0, 4. Okay, so you want to pick 2 points that, as best as possible, go through the grid, and preferably aren't like right next to each other. They're spread out. Okay, then once I found my 2 points, I can label them 1 and 2. Doesn't matter which one I pick as 1 or 2. I went with 1 down here and 2 up here. Okay, and so we need to put values in there. So y2 is the y coordinate for point 2. And here it is. Snap, it's 28. y1 is the y point for my first point, and that is 4. So here are the points. 28.0 meters per second minus 4 meters per second over x2, 8 seconds, minus x1, 0 seconds. And then we do some math. Boom, 3.0. So what are the units that we should use there? Well, this is meters per second divided by seconds. Okay, meters per second, which is meters per second squared. So that is an acceleration. Okay, what does it mean? It means, let's say we are starting with an initial velocity of 4 meters per second. Then this tells us our velocity after 1 more second is going to be 3 meters per second faster. Okay, so after 1 second, our velocity should be around 7. Okay? Okay. How many sig figs should we have? Wow, that's a good question. This, look at that precision. 8.0. This isn't just 8. Okay, 8.0. Okay? However, here, our timer isn't very precise. Okay? Is this really 1 second? Maybe it's 1.1 or 0.995. Okay, so we don't know how, this isn't very precise. So we need to only have 1 sig fig here because we only have 1 sig fig here. Okay? Okay, what is our b value? Well, the b value is our y-intercept. So let's take a look. Boom, crosses the y-axis right here at 4 meters per second. There it is. Okay, so b equals 4.0 meters per second. What a lovely initial velocity. Okay, what is our mathematical relationship? It happens to be y is equal to slope, 3 meters per second squared, times x, which secretly is time, plus b, which is 4 meters per second. Okay, there's our mathematical relationship. That's the relationship for that line. Okay, if this car continues at this rate, what will be its velocity after 14.7 seconds? If the question was, what's its velocity after 4.7 seconds, I could just look at the graph and be like 4.1, 4.2, 4.7. And I get around 18 meters per second. But 14.7, that is nowhere to be found over here. It's way over yonder here. So this is somewhere up here. So we're going to use our old pal mathematics. Okay, here's our formula. 3 meters per second squared times x, which is time. How much time? 14.7 seconds, plus our b value, which is 4 meters per second, our initial velocity. Put the numbers in. 3 meters per second squared times 14.7 seconds plus 4. Okay, meters per second squared is meters divided by seconds squared, or seconds times seconds. So when we multiply this by seconds, this one of these cancels out with that one, and we're left with meters per second. So final answer, 44.1 plus 4 is roughly 48.1. However, sig figs. How many sig figs should we have? Well, we only had 1 here, so our answer can only have 1. So what does that look like? 48.1 to 1 sig fig? Well, that is 50. Okay? That's the level of precision we can be confident about. Okay, 50. So that 0 is not significant. The 5 is. The 0 is just a placeholder. And so that's our final answer. Okay, so the velocity after 14.7 seconds is around 50 meters per second. So I hope that made sense. I hope you were able to follow that along and get it on your paper, and it should set you up for much success in the homework. Have fun.